now we have Miriam Redi, and the subject today is the science of knowledge equity. So a bit of bio, Miriam, and then the floor will be yours.
Thank you.
So Miriam is a research manager at Wikimedia Foundation and visiting research fellow at King's College London. Formerly, she worked as a research scientist at Yahoo Lab in Barcelona and Nokia Bell Labs in Cambridge. She conducts research in social multimedia computing, working on fair, interpretable, multimodal machine learning solution to improve knowledge equity. So put your hands together and give a very warm welcome to Miriam.
Thank you. Thank you so much. Yeah, good morning, everyone. I hope you had a nice coffee break. I am super happy to be here. I think this is, I don't know, the 6th year I'm at the Data Science Festival, so I'm very happy to be around and tell you a little bit about the research that we do at the Wikimedia Foundation. So to start, I'm going to talk about something you probably all know very well. Wikipedia is the largest online encyclopedia that anyone can edit and access for free. And I'm sure you know Wikipedia, and I'm sure you also know that the knowledge in Wikipedia is not set in stone forever. Its knowledge is in continuous evolution thanks to the amazing work of hundreds and thousands of editors from all around the world that curate, improve, and create the content that you see every day. And the output of this open, volunteer, collaborative work is quite astonishing. So as of today, Wikipedia exists in around 300 languages, spanning more than 50 million articles. And again, it's in continuous evolution. So about 10 million times a month, we get edits on Wikipedia article. And the output of this process is seen by quite a few people. So depending on seasons, lockdown, etc., we get in between 15 and 20 billion page views coming to our site every month. And so I just want to pause because these are very big numbers, as you know, the output of an open space on the internet. And actually, because Wikipedia content is open and everyone can reuse it and repurpose it for free, the actual readers of Wikipedia content are not only the people that we record on our servers, because many search engines and Home Assistant, they actually repurpose the content for their customers, Wikipedia content for their customers, and so actually the audiences that we have is much more that we can actually see on our site. So it's quite a big endeavor, and it's completely volunteer-based. There exists an organization who operates Wikipedia and supports the volunteer community that create the content that exists, that you see every day, and that's the Wikimedia Foundation. So we are a non-for-profit organization. We are about 500, 600 people these days. And what we do is that basically we provide support to free knowledge communities. We provide, for example, data centers, server support, legal support, fundraising support, comms, events, etc., and also innovation support. And that's why there exists a research team at the Wikimedia Foundation. This is us. We're just 8 people. And we come from all spaces of computer science, theoretical physics, human-computer interaction, and we essentially try to bring innovation into Wikimedia projects by supporting free knowledge communities. As you can imagine, Wikipedia is a large socio-technical system with many open data and research questions. So with 8 people, we cannot necessarily do much, so we collaborate with different academic institutions from all around the world that kind of expands our research capacity and help us working on long-term research questions that can help us hopefully improve free knowledge ecosystems. So what do we do? If you're familiar with what research labs do in industry, basically we do research towards the strategic goals of our organization. And our strategic direction looks like that. This is the strategic direction of Wikimedia Foundation and the whole movement of Wikipedia. And the main principle of the strategic direction is called knowledge equity. And knowledge equity is that principle that is encouraging us to bring into our projects those knowledge and communities that have been left out by structures of powers and privilege, and that is encouraging us to design technologies that can break down the social, political, and technical barriers preventing people from accessing free knowledge. This means that essentially we want free knowledge to be accessible for everyone in the world, no matter the language they speak, the culture they have, where they're from, etc. So that is quite an ambitious goal, and so that is why lots of research is needed. In practice, how we operationalize this ambitious goal is by implementing 3 different research priorities. And we're going to just see one, because I can speak for 5 days about all the research that we do. So the first one, which is going to see today, is addressing knowledge gaps, which is essentially doing research so that we can help all the knowledge that should be on Wikipedia to be on Wikipedia, and everyone who should access Wikipedia to access Wikipedia. The second one, which is extremely important, is about improving knowledge integrity. Wikipedia is open, and its openness, and it's also its vulnerability. So we need to have lots of research initiatives to make sure that we help communities preserve the reliability of the knowledge on Wikipedia and against malicious attacks. And the third one, as a research team, we are a kind of central hub for all researchers, data scientists who are interested in working to understand Wikipedia or with Wikipedia data. So we provide data sets, tools, events, and generally a network so that the research community is interested in growing Wikipedia with us can thrive. So how do we do all this? By being fully open. So all the research that we do is open, meaning that the code that we produce is open source, the paper that we publish, they are open access, the data that we have is open, but also, for example, you can read the evolution of our research projects. We have a specific wiki where you can read the evolution of our projects. You can read if you're really interested in the content of the chats of our teams, because they're all public on IRC. I don't know who you know IRC is a very old way of communicating, but you can read that. So you got it, we're open, and that is the only way in which we can do all this research and support free knowledge community. So let's get a bit into the more concrete part of the presentation. So I'm going to tell you a little bit what we do to address knowledge gap in Wikimedia projects. So with basically our whole organization is the main direction is to get towards knowledge equity. One of the missions in our team is to provide tools and data to make us understand how far we are from reaching that goal, and also build tools that can help us get there through the technologies that all of us are familiar with, large-scale data analysis, machine learning, etc. Now, the first step to implement this mission is to actually simplify a bit this notion of knowledge equity. Knowledge equity is a very complex notion, so the first step that we did is to operationalize this notion into smaller, more atomic, measurable components that can help us track in our progress towards knowledge equity. These components are knowledge gaps and are all those inequalities that prevent us from reaching knowledge equities. If you're not familiar with knowledge gaps, you're probably sadly familiar with one of the most famous knowledge gaps in our, let's say, at least on the web, which is the gender gap. The gender gap manifests itself in many different forms in our lives. It exists on Wikipedia as well. You probably know that on Wikipedia, about 80% of the biographies are about men. But also, the gender gap is not only on content. Recent research from our colleagues in the research team has shown that about 75% of the page views coming to our site come from people who self-identify as men. And this gender gap becomes even wider when you consider contributors, so people who actually write Wikipedia. So the gender gap is, sadly very popular, and it's definitely very important to analyze and try to bridge. But there are many more such inequalities that exist, in the world and by reflection on the web and on Wikipedia that we want to study, and measure, and address. And so there is this multi-year research program that is called Addressing Knowledge Gaps. It's not a very creative name, but gives you the idea of what we do, where basically we are trying to get to the goal of addressing knowledge gap in 3 main steps. The first one is about systematically identifying what are the inequalities in Wikimedia projects beyond gender gap. The second one is to use the technologies that all of us are familiar with to basically map these knowledge gaps into metrics so that we can understand what is the extent of these inequalities in Wikimedia projects, for example, these numbers that I just showed you. And the third one is to build tools like classifiers, recommender systems that can help free knowledge community bridging these gaps. So the more data-heavy part is on the first 2. So I can speak about any of these. Yeah, I'm just trying to focus on the first one, but I'm happy to answer questions about any of this. So let's talk about identifying knowledge gaps. In order to understand what the inequalities in our projects are, we need to first understand in depth the nature of the socio-technical ecosystem that is Wikipedia and its other projects. So there are 3 main pillars of the Wikimedia ecosystem. And these are the readers, the contributors, the readers who read the content, the contributors who produce the content, and the content itself. So we're doing lots of research to understand each of these spaces separately so that we can understand what are the gaps that we have. And I want to focus specifically, because here we're talking about very large data, about our recent research on understanding readers. So readership research is, again, we are researchers, so we kind of draw roadmaps and think long term. So this slide is just about, we have lots of work to do. It's a multi-year research project, etc. But let me tell you a bit how we can study and observe readers from our data. Basically, we have this large data that is made of web request logs. Web request logs are long logs from our servers, where every row is an entry, is a request that comes to our site. And for each request, you have a bunch of information about what page the user requested. We don't identify users, so there is some information about the IP and the user agent, but we don't identify users, so there is not, it's not personalized information, let's say. But then, so we have this large data set, and when it comes to understanding readers and understanding reader patterns, we need to try and draw some traces for each readers. So because we don't have individual identifiers for readers, we have to essentially make up individual fingerprint for each of these lines that we have, or these rows that we have in our servers, based on the IP plus the user agent. And this is the fingerprint that is the best way in which we can identify a user, and it's the most privacy-preserving way, because then we can just use the we can just get rid of the information about IP user agent and use some hashing function. Anyway, once we have a semi-fingerprint for each of the users, we can understand, we can put together all the rows that belong to same users and do some kind of traces to understand what navigation patterns they had across our sites. So there are several initiatives that use these same kind of techniques to identify readers and to trace readers. And I just want to give you an idea of 3 main lessons that we learned by doing readership research. The first one, and in Italian I would translate this finding with, we discovered hot water. So basically it's nothing new, but readers' interaction are diverse. People come to our site with different information needs and with different devices, and from different parts of the world. And each of these individual characteristics make their navigation different and their experience different. And so we need to make sure that people that are coming with these different devices, information needs, and geographies, they have the experience and the knowledge that they need. The second lesson that we learned is that images are important for our readers. And we're not going to get away with one slide for this because you don't know probably, but my background is in computer vision. So I've been working a lot on images, and I've been very passionate to understand the role of images in free knowledge. So we're going to have a 3-slide digression about studying how images are important for readers. Okay, the role of images in free knowledge. So we know anecdotally that potential images can be extremely useful in free knowledge ecosystems because images can help understand the content better. They can help communicate across languages, and they can simply make us relate to very obscure concepts, such as, for example, black holes. We have anecdotal evidence. We have some experimental psychology research that tells us that images can be important in instructional settings, but what we don't have is large-scale research that can tell us about how images become important in large instructional settings, free knowledge ecosystems such as Wikipedia. So we started doing some research, and we started doing some research from the most basic question that we have around how images are important for our readers, and it's about how readers interact with images. So understanding whether images, what is the role of images in navigation and how much people are actually interested in images when reading Wikipedia. And when I say people, it's also me, so it's interesting because as a Wikipedia user, I kind of see myself in some of these findings that you will see. So how did we do this research? Through data. We collected large data from English Wikipedia, and we saved 4 weeks of data from March 2021, where we collected all page views and image views on English Wikipedia. At the time when we did our research, English Wikipedia had about 5 million images, and we extracted the hell out of computer vision features because I was in the research team, so in the team that did this work, so I was like, yeah, let's use computer vision. So we started a bunch of features just to basically break down the analysis into more, say, fine-grained findings, and also we extracted a bunch of information from the pages that people see. So I'm going to skip the methodological part because of time, but I'm going to give you some insights about the results that we found. The first result is that people are actually interested in images when they read Wikipedia. So about 1 out of 30 times we visit a Wikipedia page, we also click on an image. And if this doesn't seem a lot to you, I can tell you that compared to other interactive parts of the page, this is a huge number. So when we compare with citations, for example, and citations, as you might know, they are a core component of the encyclopedia because it was ensure the reliability of the knowledge. So the interaction with citation is 10 times lower than the interaction with images. So this is telling us that images are kind of much more interesting than other interactive parts of the page. And the same happens with other parts of the content. So it's good. Images are interesting for readers. And especially they are interested in 4 main cases that we found in our data. The first one is about complex objects. So we are very interested in on Wikipedia and images around visual arts, vehicles, anything that has inherent complexity in the image. And I don't know how much you're passionate about cognitive psychology, but this is confirming a lot of what we see from cognitive psychology, where basically they say that there is an inverted U shape, right? This, between visual interestingness and visual complexity. So this is kind of confirming through large data some of the findings in that field. The second case in which we engage with images is when it comes to visiting the world. So people use the encyclopedia to look at maps, landmarks, places around the world, which it's a beautiful use of the encyclopedia, at least for me. The third one, and maybe this is not very interesting for other people. For me, I've been studying visual preferences of web users for many years, and consistently across our research and research from other institutions, there is a finding that is web users engage much more with images when there is a face in it. This doesn't happen on Wikipedia. Like, mostly people ignore images of faces unless faces come from less famous people, from biographies that are less popular. Because, you know, you're probably not going to go on Wikipedia to check the latest Lady Gaga picture, but maybe for people who are less popular, this is the only way you can have to access actually those images. And the fourth one is people engage with images when articles are of lower quality or they are, you know, very short. And this, again, it makes sense because in absence of normal text, you know, traditional form of knowledge, you need to resort to, you know, more multimedia or interactive forms of knowledge to satisfy your information need. So people tend to use images a lot in lower quality articles, you know, the stubs, the shorter quality articles. But not only that, we saw that in shorter articles, lower quality articles, engagement with non-traditional forms of knowledge is much higher. So we see that, for example, people tend to engage with citations much more when articles are low quality, which again makes sense because you don't have the information that you need, so you need to resort to whatever else Wikipedia is providing you. And we also found that, you know, this problem of content quality is very present across different aspects of reader navigation. We saw that the navigation on Wikipedia often stops when readers reach lower quality pages. Because, you know, again, probably not finding the information that they need to either go out or follow a link that brings to a place where they get the explanation that they need. And so this sadly concludes the visual part of the presentation, but this also brings me to the third lessons from a reader, which is article quality is very important. Often the navigation on Wikipedia pages is very short and, you know, and very fast, and it stops at low quality articles. So nurturing the quality of article for this type of very short and fast navigation is extremely important. Okay, this was just an idea of some of the research that we need to do in order to understand part of our ecosystem so that we can identify our knowledge gaps and the inequalities in Wikimedia projects. Without understanding our readers, this is our research, but other people have done similar research across readers, contributors, and content, we can't have an idea of what are the inequalities in Wikimedia projects. And so we recently, to help basically us and everyone who's using Wikipedia data understand what are the actual inequalities in Wikimedia projects, we did a qualitative analysis, which, believe me, for me was a very big effort because I'm a computer scientist and it's very difficult to do qualitative stuff, but it was very nice. So we analyzed a bunch of research around readers, content, and contributors, and we put together this taxonomy of knowledge gaps, which is a structured list of all possible inequalities you can find in Wikimedia projects. And this is useful, for example, for us to understand, you know, where we should start acting and bridging knowledge gaps. For example, there is a geography gap, there is a technical skill gap in content, there is a multimedia gap, so there are many of such gaps. But it's also useful for people who are using this data, and pretty much everyone doing natural language processing is using this data, to understand what are the potential biases that they can find in the data that they use to model languages at scale, right? So yeah, there is a 45 pages paper on arXiv if you're interested, if you really have nothing to do. And you can read all about knowledge gaps. All right, so that was about identifying gaps. So now we have a systematic definition of the different knowledge gaps in Wikimedia projects. The next step is to design ways to measure those gaps. And here, this all our knowledge about tagging, classifying content becomes very useful. So basically here the idea is that for each of the gaps in the knowledge gaps taxonomy, we can design a metric. I don't need to tell you what a metric is, but it's just a set of numbers that can help us understand the extent of each of these knowledge gaps. So this is ongoing. We are working on that. We have a bunch of data missing. We have no idea, for example, how to measure readability of a text across languages. There are many, many problems. But I would just want to give you one example of the type of complexity that it involves measuring these gaps. One of the gaps that we have in content is the cultural background gap. And this gap reflects the extent to which wiki, for example, Italian Wikipedia, covers articles about local territories where the language is spoken. So for Italian Wikipedia, it would be Italy and Switzerland, some piece of Switzerland, something like that. And so how do we do that? We design a classifier that, given an article, this is my hometown, is going to automatically, based on the content, understand whether it's about a local territory where the language is spoken or not. And then we can tag article about whether they are local content or not, so that we can aggregate across a whole Wikipedia and calculate the percentage of articles that talk about local context of the language. And then we can see that different languages have, different percentages of local content in their articles. And so the important thing is that we can provide this data to the individual communities, for example, Catalan Wikipedia or Italian Wikipedia, and say, hey, the percentage of articles in your language is, of local articles in your language is this much. So if you're happy, continue like that. Otherwise, just, maybe it's important for the communities to act. And so we're actually gathering all this data similar to cultural background gap. We have much more of these types of gaps. We are putting this data together in a tool. This is called the Knowledge Gap Index, and will allow us, the communities, and whoever wants to basically navigate through different data about the gaps. It doesn't exist yet, so hopefully the Data Science Festival 2023 I will be able to show you, but we're working on that. I think I have a few minutes left to tell you just a few initiatives about the last piece of addressing knowledge gaps, which is actually building tools that can help us bridge those gaps. Here, this is really about exploiting the knowledge that we have in recommender system machine learning to build tools that can help reduce individual gaps in our taxonomy or individual problems that we find in Wikimedia projects. Before I tell you a little bit more about this, I want to mention the principle through which we work when we think about bridging knowledge gaps. So here we're talking about we're talking about a community of humans from all around the world that, despite this shouldn't work in theory, it actually works in practice. So the content that you see every day is quite extensive and reliable. And this is thanks to the self-governance of the community, to the amazing work that the editors do to regulate and curate the content, right? So when we insert an automated methods or a machine into this community, we really need to be careful about make sure that the machine actually contributes to the community rather than replace individual members of the community. So we work in this machine-in-the-loop approach where the machine is helping reducing the space of search, for example, or helping, do some of the tasks faster, but is essentially acting as one member of the community rather than replacing them. So what this means in practice is that how we work when thinking about bridging knowledge gaps is that we talk to communities, product teams, different institutions, and we identify problems in content. So for example, there is on Icelandic Wikipedia, there is a problem of, is missing many images, for example. So what we do in the research team is that we build the system to help bridge this content gap. For example, we build a system for, that can help discover images to be added to Icelandic Wikipedia. Now, the next step is not we use this system to automatically add images to all Icelandic Wikipedia article, because this is not how we operate. We actually embed this system into a tool that is community facing. And then the last word about whether the output of the model is useful or not, or is correct or not, is always in the hands of editor. They have the complete agency on the machine decisions. So I'm going to give you one example, maybe I have time. There is a big problem in many Wikipedias that many articles are missing links. So, and this is a problem because people can't necessarily easily navigate from one article to the other. Some articles are isolated from the rest of the wiki, etc. So we identified this problem. We found a solution that is a link recommendation model. This is essentially entity recognition, if you're familiar with that. Basically, you identify in a piece of natural language text a anchor word that could be potentially linked to another Wikipedia page, and then you identify exactly what is the Wikipedia page that you should link to. The model works, it's been published in main conferences, it's been evaluated in all sorts of stuff, but the important thing is how we apply that. We apply that by embedding it into a interface that editors use to, interact with the model, right? So in this interface, they will see suggestions about potential words in the text to be turned into blue links. They will say whether the link is, the suggestion is good or not, and only if the suggestion is good, the edits will be saved. And by doing this process, they not only improve the content, but they also learn, this is especially for newcomers, so they learn some of the practices and on how to edit Wikipedia. We did the same for images. I sadly don't have time, but yeah, Wikipedia is missing many images, so we did the same for images. And I think I'm going to conclude with that. So I hope with these 30 minutes of introduction to our research, I gave you an idea of the complexity of the socio-technical ecosystem we are operating with. When we actually think about solving knowledge gaps, while we initially think about different pillars, readers, contributors, and content, we can't necessarily think about these entities, about separated entities, right? Because readers read content and then become contributors and produce that content. So we need to think about the whole complexity of the social technical ecosystem when we design solutions to help improve knowledge equity. And this can be done only through data analysis or machine learning or computer science. We really need to have all sorts of disciplines involved because of the impact that then it has on Wikipedia and on the broader web. And with that, I thank you very much. As you can see, we have many open questions. If any of those open questions are interesting for you, please reach out to me. I think I have, yes, these are my contacts. Yes, thank you. Do I manage it? Okay, please. I'll come to you. Yeah. Sorry? What we're doing here. No, this is purely based on, I don't know if it's exactly what you're saying, but this is based on the history of Wikipedia, right? So we know that certain words tend to link to certain pages, depending on the context and depending on the language, depending on the type of articles. So we actually have a system to take all this contextual information into account to get the right link to be suggested. I don't know if it's alternate link. I haven't done necessarily this specific work, but I can send you the more information. But it's what I can tell you is that it's based on purely natural language processing that is learning between associations between words and the historical links. Yes. I think there was one here. Yeah.
So in relation to like knowledge equity and knowledge gaps,
Yes.
has Wikipedia factored in kind of the reduction in attention span for the general public in regards to kind of simplifying or an easy read version and maybe like a wiki light? Because my hypothesis is that Wikipedia is accessible only for a certain percentage of society who's more educated, but in relation to the wider population kind of behavior change and kind of combating misinformation, is that something you've thought about?
I love this question. So there are different aspects to answer your question. So there are different ways of consuming information these days that are not necessarily the 2001 style of Wikipedia that we have, right? So the interface has never changed. It's blocks of text and things like that. So our product teams are actually thinking about new ways of repurposing content so that it can kind of be consumed more easily. For example, there is an initiative called Wiki Stories that should be out soon, where editors can create Instagram kind of like type of stories out of Wikipedia articles. So basically these are images with snapshots of Wikipedia articles that you can access directly from the Wikipedia articles. So this is a pilot that should be coming out soon. The other thing is that we're trying to invest more on anything that is more visual. So while text is extremely important, we have no idea, for example, about what the role of videos could be on Wikipedia. We're trying to investigate what can be done there to improve the visual aspects of the encyclopedia.
So can you make a wiki light or an easy read Wikipedia?
So there exists, yes, so there exists a simple English Wikipedia already, but it's much, much smaller. It's not that I can make, so whatever we do is in collaboration with the communities. So what we can provide as tool, for example, is tools to measure the complexity of the content, right? And this is something we're working on, the complexity and the readability of the content. So we can flag articles are being too unreadable or too complex, so that then editors can act and try to build for example, a simple English Wikipedia or a more compact version of the article. There are initiatives that are trying to think about how to allow content to be customized so that we have different levels of complexity in the text. I don't know about a Wikipedia Lite specifically. This would be a bigger conversation. One interesting initiative that is not from Wikimedia Foundation is a project called Wikidia, that is Wikipedia for kids. It's very cute. I invite you all to check it. So there are actually, it's a Wikipedia with a bunch of cute pictures and kids topic, and it's very explained very easily. But definitely, the communities and the foundation are thinking about ways to make it more accessible. Because also, for example, Wikipedia exists in 300 languages, but there are more than 7,000 in the world. So what about those people who don't speak those 300 languages? How we can serve them in a way that, they can access the content? Many open questions. So definitely on the spot. Yeah. I think there was one there. Yeah. You stop me whenever we need to stop. Yeah. Yes.
First one is, have you considered, investigating how much this knowledge gap transfers to bias in AI when, the AI model is training on this data, which is very awesome. And the second question is the idea. Is it a small idea, but I don't know if you've considered using the models from OpenAI, like DALL-E, for image generation for some of your text.
Yeah.
And
I love it. Yeah. For generating images, you mean? Sure. The problem is I forgot your first question. Yes, about bias in AI. So there exists. So what we can provide is ways to say this is how much our data is biased. We've seen by the behavior of many of these natural language processing tools that there exists bias. You know, we've seen it in computer vision that there exists bias. So rather than doing the research ourselves, we are encouraging the AI community to say, look, these are the problems that you can find. You know, help us amplify our capacity and you know, try to rebalance it, right? So we've done some of the research ourselves, but we can't just do it for all sorts of the complex dimensions that we're looking at. For the second one, I love the image generation question. Image generation is a very interesting topic for me. I think that there are interesting aspects about licensing. So all images that go on Wikipedia are free and are Creative Commons licensed. What happens when we have generated images? Who is the owner of the copyright? Is it OpenAI? Is it everyone who has created the images that go into the AI and that output then the automatically generated images? Is the person who actually wrote the prompt to OpenAI to the DALL-E? So there is that open question, but definitely this is something that because of how photorealistic these things have become, I've been thinking about this lately. So this is interesting. So if you are working on these topics, let's talk about it later. I think there was someone here. I haven't looked at there. Sorry, was there someone from here? I haven't looked at. Okay, let's.
Is there potential for automated article generation to fill in some of those content gaps in different languages?
There is. There is an interesting new paper coming out about trying to fill knowledge gaps through automatic generation. I think it just came out about the potential biases that these can incorporate. So unfortunately, because of the lack of interpretability of these types of systems, we're not necessarily sure about what kind of biases this would carry on. So it can become a little bit risky. There are aspects of articles that can be at least supported by semi-automated generation. For example, there is an interesting paper from EPFL that just came out on the archive about automatically generate article description, so the small description that you have just below the title. There is potential for caption description, for image captioning. There is some potential for suggestion of references. So we are going towards that, but the complexity of generating an entire article is just too big and the transparency is just too low for us to say, let's try to incorporate this. There is a bit more work to be done. And also they work mostly only for English, so this doesn't necessarily apply to 300 languages. Yeah, but definitely another technology like image generation that we're looking at. Stop, yes. There is a big stop in front of me, sorry. I speak too much. Thank you.